Let's just look at sulfur rather. I keep interchanging phosphorus and sulfur. We're going to look at sulfur, which is the next one across from the periodic table, with atomic number 16 and atomic mass of 32. S1632, and therefore the electronic configuration would be neon 3s2 3p4. Neon 3s2 3p4. That's the sulfur there. Let's pluck it out from our deck here. Seen it as yet. Phosphorus, no, we're talking about sulfur with an atomic number of 16 and an atomic mass approximately 32. We're going through to bring out our focus on sulfur here. Here is it, sulfur, 1632. And from our notes, let's some sulfur. Atomic number 16, atomic mass 32. Silicon 14, phosphorus 15, sulfur 16, and 32.058 is the more precise atomic mass. It's tasteless, it's odorless, it's a brittle solid looking like yellow. It has some allotropes, alpha, beta, gamma, and delta sulfur, S8, 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 and S7, which is the integral, alpha, beta, gamma, delta sulfur. And it's rhombic for the alpha, and beta sulfur would be monoclinic, and gamma would be amorphous sulfur. Alright, it will react with oxygen to give you sulfur dioxide, and more concentrated oxygen or even ozone, it will give you sulfur trioxide. Reaction SO2 plus H3O will give you H2SO3, which is sulfurous acid, and further reaction we have SO3 plus H3O give you H2, or H2 will give you H2SO4, which is sulfuric acid. And this is one of the most important reactions of sulfur and an important use of sulfur in making sulfuric acid. We have also oleum, H2S2O2 plus water give you H2SO4. And 2SO2 plus O2 give you 2SO2, which is sulfur trioxide. So we have crystalline structure of sulfur, which is the rhombic sulfur, and then you have the monoclinic, which is the other allotrope, and then you have the amorphous sulfur. Let's go on to some further thing. As we mentioned sulfur, remember this reaction to get that offensive or repellent smelling gas, call it hydrogen sulfide, and we get that by reacting iron sulfide, FeS, with dilute hydrochloric acid or dilute sulfuric acid. We get this hydrogen chloride gas, which is offensive and repellent smelling, foul odor, like rotten egg smelling gas. And it also can be formed by eating paraffin with what it is now. CXHX and something that will give you H2S. But let's look further here. Sulphur. Okay, sulfur allotropes, rhombic, alpha, beta, gamma sulfur. Alright, alpha sulfur, rhombic, beta sulfur, monoclinic, gamma sulfur, amorphous. Okay, let's see what else we have here for the sulfur. Yeah, FeS plus HCl give you FeCl2 plus H2S, and likewise CXHY plus sulfur give to H2S. That is the production of H2S gas from paraffin or from iron sulfide with dilute hydrochloric acid or dilute sulfuric acid to get that foul smelling repellent gas. And as you know, sulfur with its old name, brimstone, yeah. Fire and brimstone, that's sulfur. That's some very explosive effect there. Used to use it at holiday time, Christmas, and you get the sulfur powder, and you put a rock over it, and friction, and it gives off a explosive sound with light and heat. But the most important use would it to reaction in commercial use to bring sulfuric acid, which then has very important use. Sulfuric acid plus base would give you salt plus water. We call that acid plus base neutralization there. Salt plus water. Then you do your titrations and you calculate how much molecules you get from the end product of the reactions. That's a brief thing of sulfur. We have to do some more work on sulfur, but that's just a brief look at sulfur. Sulfur dioxide, sulfur trioxide, oleum, H2S2O2 plus that sulfur give you sulfur. Let's see what it is here. That's in giving you that silicon 14. Okay, yeah. The oleum 2SO2, H2S2O2 plus water give you H2SO4, and 2 sulfur dioxide plus oxygen give you 2 sulfur trioxide. Crystalline structure with the rhombic and the amorphous or the prismatic sulfur. All right, we'll have to come back. This is just a brief look at sulfur. We'll have to come back and give some more properties and reaction of sulfur at another time.